In this video, I'm going to show you how to do a continuous time deterministic system example. The first thing we want to do is choose continuous and deterministic from the system description. Then we want to set the number of dimensions of our dynamical system in dim and choose the maximum degree of our barrier certificate in max b degree. The Lagrangian degree is optional and defaults to the size of the dimensions. Now we want to choose the lower bound and upper bound regions of our state space X, where we separate each dimension by a comma. We'll do the same for Xi, which is our initial region, and also the same for our avoid region Xu. If we have multiple avoid regions, then we can click the button Add Avoid Region on the left-hand side, or delete them if we accidentally add too many. After this, we will want to set the dynamics. We're going to do this in a format that works for SymPy, a SymPy expression where asterisks are used for multiplication and double asterisks are used for exponents or powers. The base of this is x1, x2, x3, so there's no x0, and it's important to get this formatting correct. Here you can see that we have 1.5 multiplied by x1 to the power of 2, or x1 squared, and we also have half times x1 to the power of 3, or cubed. The parameters lambda and gamma are optional, and we can choose the solver that we want between MOSEC and CVXOpt. On the right hand side you can see a little checkbox saying parallelization. If we select parallelization checked, then the maximum b degree of our barrier, we will choose all of the even values up to and including this value and run them in parallel, returning the first barrier certificate that we get that is correct. If it's not checked, we will simply use the max b degree value and run one simulation using exactly that number. When we're happy with the parameters we've selected, we can click Find Barrier, and this will generate for us a barrier certificate with a lambda and gamma level set, respectively. In this case, we were using a jet engine example. You can also see the results in the terminal here. So we can see that the degree that was chosen for this barrier is degree 2.